was at 0 equals 12 minus 28x plus 12x squared. And the question came up, can I factor to get the roots? You can't factor in this case because it's not factorable. There are no factors of 144 that sum to negative 28. So we'd go back and use quadratic formula. If it was a calculator problem, then you would use the calculator. So assuming it's, the decimals are kind of gross, so let's assume it is a calculator problem, and we're going to do a lot more with calculator problems tomorrow. You would still need to show the setup of the quadratic formula. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we see that we get 2 roots. And where's my graphic? So you'd have your 28 squared minus your 4 times 12 times 12. So it gave you 208. So the square root of 208 would be added to 28 and subtracted from 28. I mean, it doesn't hurt you or help you. So somebody, I don't have my graphic calculator, I don't know how to use that silly little calculator. Give me, I know the first 2 decibels, I didn't write down 3. So it's 0.57 what? Uh-oh. You got, 5.56, got it. There you go. Thank you. I've rounded when I wrote it down just to have it down. So you have to have your 3 decimals. You can truncate or round, so it doesn't matter. And then we have our number line. So we have to determine if the numbers to the left and to the right are positive and negative. We know that we cannot have a number greater than 0. And we also know that we can't test a number greater than 3 because the length of one side was 3. And we obviously cannot have a height of 0. So plugging in something a little bit smaller, we're going to look, I would look back up here at this point. So if you think about 0.5 squared or something like 0.25 squared, that's going to make that number smaller than our other number, but we're adding 12 to that, so we're going to get a positive, a negative, and a positive. And again, using the decimals, you'd have a calculator, so you could just plug right in numbers less than, greater than, and in between. Okay, so we are looking for a max. So a max occurs when we change from negative to positive, from positive to negative. So my max is going to occur at 0.565. That 0.565 represents my height. So then you have to find your width and your length. So you have to do 4 minus 2 times 5.65. And again, I rounded, so you should have 3 decimals. And watch your units, so these are feet. Okay? So looking at the next example, it says a rectangle is to be inscribed under the arch of a curve. What is the largest possible area the rectangle can have, and what dimensions can that rectangle have? So here we have a trig function. You're looking at y equals the sine of x, right? Yeah. And I believe our interval is 0 to pi. Maybe? Okay. So a rectangle is to be inscribed under the arch of a curve. I think the arch was just drawn in. For whatever reason, it deleted it off my PowerPoint. Okay. I probably have your note guide here. All right, so draw in a rectangle under that picture. So if you draw in a rectangle under y equals sine x, we would have a max here, and then a line straight across. So here's my rectangle. So these points on that rectangle, the area is going to be with respect to the graph. So this is the curve y equals sine x. So on the sine graph, this point right here is going to occur at the sine of pi. So that's why I asked if this was labeled for you, because I know that the beginning half of sine goes from 0, 0. Its max is at pi halves, comma 1. And then it goes back down to pi, comma 0, because sine is going to be those y values. So it's moving up and back down. So these points on my rectangle are unidentified points on my graph. So the area of the rectangle would be the length here. So the entire length is pi. So we could label these mini lengths as x. So the length of the rectangle is kind of like the cardboard box. It would be pi minus 2x. So the whole length was pi. If we made the outside pieces x, the length of the rectangle is equivalent to pi minus 2x. Everybody okay with that? The height or the width of the rectangle then would be this piece from here to here. So what would this represent? Well, that would represent the y value, right? So that would represent the y value of this curve. So it's x units in. So the width would kind of be like sine x. Because this point right here would be x sine x according to my curve. Because the equation of the curve is y equals sine x. So your x units in and sine x units up. So area is equal to length times width. So it's equal to pi minus 2x times sine x. We're trying to maximize area. So you have first times derivative of the second plus second times derivative of the first. Remember, pi is a constant. So we get pi cosine x minus 2x cosine x minus 2 sine x. And I need to know when that is equal to 0. So once again, you'd go to that graphing calculator and you would put that into your graphing calculator and find the 0 of that function. So a lot of optimization questions are calculator and senses that we can't just simply get these answers. This isn't something I expect you to know. And it's not like an easy answer. So this occurs when x is 0.710, and I did do 3 decimals for that one. So once again, you would need to know what's happening to the left and to the right to confirm that that is in fact your max. And we can see that it is positive to the left and negative to the right. We could also see that from the shape of this curve. So your dimensions would be pi minus 2 times 0.71 and the sine of 0.71. Which is 1.722 and 0.652. There are no given units with this, so those would just be units. Okay, find the point on the parabola y equals x squared closest to the point 1, 4. So in our heads, we're imagining this parabolic curve. So here's your y equals x squared. And we have the point living out in space, 1, 4. So if I wanted to find the point on the curve closest to a point out in space, what's that called going from one point to another? Like, what am I finding between that? What do those green lines kind of represent? What am I finding? Distance, exactly. Excellent. So I'm trying to find or minimize the distance formula. So I have my curve, I have a point, and I'm trying to minimize a point on that curve using distance. So the distance formula is a variation of what? What's this kind of look like? If you never recognize, go ahead. Pythagorean theorem. The distance formula is really just a modification of Pythagorean theorem. So it's kind of like your a squared plus b squared equals c squared. So d is kind of like the square root. So this is like your a and your b. So a is the length between those. So we're kind of finding a right triangle in a sense when we're looking at distance. Okay? So obviously we're trying to minimize distance, and our equation is y equals x squared. So I'm going to make my x1 and my y1 from x squared. So distance equals, that's my substitution, x minus x2 squared plus, so now instead of y1, I'm going to use x squared. And then how do you think I'm going to get rid of the x2 and the y2? What other information do I have that I could use for this distance? What distance am I trying to minimize? Yeah, the 0.14. So this is my beginning point. This is my ending point. So now I have a single variable equation that I want to minimize from a point to a point. So it's like my point A to my point B. So I got to find the derivative. How many of you like taking derivatives with fractions and negative square roots? Probably not many of you, right? What could I do to get rid of the square root before I find my derivative? What could I do? Square both sides. Now, this is a little bit of an implicit when you square both sides, right? Because you have to take into account, because otherwise you had to do the chain rule, where you had 1/2, and then all of that got dropped down to your denominator. So now it's 2d times d prime, which is what we were looking for, equals 2x minus 1 times 1 plus 2x squared minus 4 times 2. What's really nice is that if I divide everything by 2, a few of my 2's are going to cancel, so that one goes away, that one goes away, this one can go away. And then we want to get d prime by itself, so we're going to divide by d, but we know that d is really the equivalent of all of this. But we also know that that's going to give me a does not exist, so we really aren't concerned with that denominator not existing. So I have 0 equals x minus 1 plus 2x squared minus 8 all over d. So we're going to find the zeros of the top. So when you're maximizing or minimizing, I think I'm going to answer a question. When you're maximizing or minimizing, the DNEs don't matter in optimization, because they're going to give you the points that do not exist. So in this case, I don't have to worry about the critical points from here. So I have x minus 1, sorry, this should be cubed in x. I missed my x over there. is all you're going to say. So then my zeros come from that top, and I'm just running out of room, which is why I erased my divides by D. So you have 2x cubed minus 8x plus x. So you can group those together to get you minus 7x minus 1. You can't do factor by grouping. You can't do quadratic formula. So again, the only way to do this is to go to your graphing calculator and find the zeros. So are we all okay with finding the zeros on our graphing calculator? Like you would enter this into Y1 and then go to second trace and then go to, I believe it's option 2, which is zeros. And then you move it to like the left and to the right and you find your roots. Can I erase what's on here to do the next part of the problem? Is anybody still copying that down? So my zeros from my graphing calculator So thinking about this point here, which of these is the most logical answer? Which is going to be closer on that parabolic curve? Yeah, the positive one, right? So even though we get 3 critical points, you have to sometimes use logic and reasoning, because this is going to go negative, positive, negative, positive. So you're going to see 2 minimums, but you need to recognize that this min is not necessarily going to be the closest in terms of this example. Okay? That is where we are going to stop for today. Your homework is page 226. You are looking at only 4 questions for tomorrow, 3, 4, 9, and 10. So